excited to be here today and to help you start thinking about doing a greenhouse gas inventory and beginning to measure your greenhouse gas emissions. I promise, as an ex-Outward Bound instructor, I won't make you tie a human knot and untie yourselves today. We will maybe do an icebreaker in a little bit, but so really the objective of today is to give you an overview of managing your greenhouse gas emissions. And as Elizabeth said, it's kind of an intensive, but hopefully we'll get you started thinking about it. So we'll do an intro to what is it, what are the principles behind it, talk about the standard that's been developed, a couple of them, and we'll take some time to just start mapping your operations. So you'll come out of today with a list, or the beginning of a list, depending on the size and complexity of your organization, of your emission sources. And we'll also do an exercise on your laptop where we can play a little bit with the data you've provided to Jennifer and that she's provided back to you in an Excel spreadsheet. So we're not going to spend a lot of time on climate change itself. We're going to kind of jump right into measuring our greenhouse gas emissions. But I know people come to our workshops, certainly, as Elizabeth said, a lot of us, it's not our only job in our organization to measure our greenhouse gas emissions or even to work on sustainability. A lot of us are doing this off the side of our desks. We might be in operations, or we might be an office manager, we might be the accountant. And so just to make sure that, starting at least on the same page, just briefly, this diagram is of the greenhouse effect. And so essentially, it's the greenhouse gases surrounding our planet that regulate temperature and make life possible, right? It's like an insulating blanket. And the sun's rays come in, the Earth, some of that heat is radiated back out, some stays in the atmosphere and makes it comfortable for us. Now, as human activity has produced more greenhouse gases, and emitted those into the atmosphere, more have stuck around, more heat is being trapped, and as we all know, our global average temperature is on the rise, and it's having increasing effects on us, and we can see those in a number of ways. I like this bathtub analogy. If we can think about our greenhouse gas emissions being sort of coming out of the faucet and filling our bathtub, which has a finite amount of sort of space in it, and the drain at the bottom being how our greenhouse gases leave by being sequestered, taken up by forests, plants, and the ocean. There's a lot more water coming into the bathtub than is leaving by the very little holes. We either need to make the drain at the bottom way bigger, or really, more realistically, we need to turn the tap off. We need to do both, but we need to turn the tap off, and we need to drastically reduce what we're putting into the atmosphere in terms of greenhouse gases in all our activities, and that's really why we're here today, right? The concentration of greenhouse gases, this is kind of the famous, and now infamous in some ways, hockey stick diagram. And we can see the point is we can see the sharp rise in concentrations of a couple key greenhouse gases, sort of starting at kind of the Industrial Revolution, and then it jacks right up. We're currently at about 387 parts per million of carbon dioxide in the atmosphere. There's general scientific agreement that we need to get back to 350 to maintain and prevent ourselves from getting to that more than 2 degrees higher than pre-industrial temperatures, at which scientists forecast very severe effects of climate change. And already we can see some of those events that we can expect to see more of. Flooding, less availability of fresh water, displacement of people as sea level rises, impact on our food systems. I know in Vancouver we see it. We're seeing it increasingly. There's been extreme weather events the last few years. I'm not sure how much you guys have been watching the Olympics. Being from Vancouver, it's in my face every day. I was telling these guys it's kind of like a cross between a street festival and a militarized zone. But they've had to truck snow in to Cypress Mountain and helicopter it in, and the sustainable 2010 Olympics is sort of, the irony is hard to miss, but there's a lot less snow on those mountains than there used to be. So we're seeing that. Does anybody feel like your business is already being impacted by the effects of climate change? You feel that in your work yet? Not yet. Yeah. I know we work quite a bit with the tourism sector in BC, and they're already concerned about, you know, on the islands around British Columbia, how are people going to get to us? It's harder to fly in a float plane in a storm. They won't go. What if the sea level really starts to rise? That rise in sea level starts to impact us. So there's some concern there about those long-term effects. But that's it for kind of overview of climate change. And what I wanted to do now is just give us a chance to get to know each other a little bit better, and also have some fun learning about some of the terms and basic concepts that we're going to be using when we start thinking about measuring our greenhouse gases. The three biggies are exactly carbon dioxide. You guys got it. It comes from, you know, we emit that when we burn fossil fuels. Carbon dioxide is released when we remove plants and trees from the forests and biomass burning. Methane, the decomposition of waste, and animal wastes, and burps, and agricultural practices. Nitrous oxide, so N2O, also in agricultural practices. Fertilizer, fossil fuel combustion. And then the other three, more rare, hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride, or SF6. So associated with industrial processes, refrigerants, and we'll talk about in just a sec, actually less common. Any questions there? Did I hear sulfur dioxide? Did I hear SOx and NOx? So ozone causing, different pollutants, not so directly related to climate change. So get to this idea of global warming potential. So we hear this term carbon dioxide equivalent. And essentially we compare the power and impact of different greenhouse gases to carbon dioxide. So we've given carbon dioxide a global warming potential, its capacity to hold heat in the atmosphere, essentially. We've given it the value of 1, and then we've compared the others to it. So you can see that methane has a global warming potential of 21, more powerful. What amazed me when I first started to understand this is the power of the bottom three compared to carbon dioxide. It's much, much rarer. But very powerful. You'll also hear the term, and later in the day we'll work with this, but the idea of an emission factor. People have probably heard about that if you started to think about your greenhouse gas emissions and how to calculate it. And it takes a unit of activity, a liter of gasoline burned, for instance, and converts it to a mass of carbon dioxide equivalent produced. So we talk about it in terms of grams of carbon dioxide per kilowatt hour, or something like that. We'll get into that a little bit later, but that's another term that we'll be coming across as we go through the day. So Ontario set the target of 6% from 1990 levels by 2014, 15% by 2020, and 80% by 2050, which lines pretty closely up with the Intergovernmental Panel on Climate Change that has said they've put out 85% by 2050 as the reduction goal that we need to work toward. The 1990 emissions in the Climate Change Action Plan reported were 177 million tons. And then I also just wanted to share with you, as you may know, Ontario is a signatory to the Western Climate Initiative, which now includes California, Oregon, Washington, Utah, Arizona, New Mexico, Montana, BC, Manitoba, Ontario, and Quebec. So not so Western anymore. Out of the Western Climate Initiative will come a regional cap-and-trade system. Now, as federal initiatives in both Canada and the U.S. sort of come online, definitely the U.S. federal bill talks about sort of Western Climate Initiative sort of pausing while the federal cap-and-trade system takes root, but very similar. But interestingly, so the 15%, the goal there is 15% below 2020, and I was looking today, and Ontario reports that in 2004, the million tons was, so your emissions were 203. So it would only get you to 173 million tons, that reduction. So Ontario's provincial goals are much more ambitious, than the Western Climate Initiative. And just interestingly, so Canadian emissions have risen about 26% from 1990. Next question is the two main the sectors that emit the two sectors that emit the most in Ontario. Did anybody take a stab at that? Electricity. Great.
Yeah, transportation and power generation.
Yep. Anyone else? Good. So apologies, this is a little bit blurry. It was the best image I could get, but yes, transportation at 31%, and then industry, which is the electricity and heat used in industrial processes in the industrial sector, coming in second, and then the generation of heat and electricity in third. And just, I find it interesting to look at the, so 2 points for that for the point trackers. And then from WRI, I just find it interesting to look globally from 2005 that heat and electricity actually is the biggest source. Interesting for us coming from British Columbia because we do have virtually all hydroelectric energy generation. Our pie chart looks very different, and transportation is huge for us. I hope that was fun, and I hope you got a chance to get to know each other and learn a little bit